Friends, good morning. Myself, Professor T.N. Oza, present before you with a new video. Today's video will be on the topic Louis de Broglie and his contribution. This is a very, very important topic. As you know, this marked the beginning of quantum mechanics. In this video, we will be covering the following points: introduction, mathematical formulation of de Broglie equation, matter waves versus electromagnetic waves, support to Bohr's hypothesis, verification of de Broglie wave particle duality theory. We will discuss all these points in a bit detail. Louis Victor Pierre Raymond de Broglie, his full name, was born in 1892, 15th August, and he was alive till 19th March 1987. He was a French physicist who won 1929 Physics Nobel Prize at a very early age for his brilliant theoretical research, which paved the foundation of modern quantum mechanics. Niels Bohr, as you know, Danish physicist Niels Bohr, in 1913 had predicted that electron, which is a particle of tiny mass, was constrained to keep moving around the atomic nucleus in certain circular orbits of fixed radius r, as determined by the following rule. Angular momentum MUR equal to NH upon 2 pi. In this equation, M measures mass of electron, U is its linear velocity, R is radius of the orbit. Therefore, UR means angular velocity and MUR means angular momentum. M is an integer, H is Planck constant, pi is another constant. So I repeat the equation: angular momentum MUR equal to whole number multiple of H upon 2 pi. Now, here in this equation, as I told you, n may have values 1, 2, 3, etc. till infinity. And Planck constant has value 6.626 multiplied by 10 to the power minus 34 joules second. In fact, this is equivalent to saying that electrons were restricted to certain quantized energy orbits. This concept, though not proved mathematically at the time of Bohr, was found to be convincingly satisfactory in understanding the results of atomic emission spectrum of hydrogen. Apart from the wave theory, Einstein had in 1905 suggested dual nature of light waves. This wave particle duality or electromagnetic radiation had prompted de Broglie to speculate comparable wave particle duality for tiny particles like electron, atom, and molecules. The famous equation relating the material wavelength L with the momentum mu was later experimentally verified by C.J. Davison and L.H. Germer in 1927-28, and it was further extended by G.P. Thomson. In physics realm, a popular joke goes as follows. Father J.J. Thomson received Physics Nobel Prize in 1906 for showing that electron is a particle, and his son G.P. Thomson in 1937 received Nobel Prize for saying that electron is a wave. Thus, both father and son meticulously earned the laurels. Actually, there is no contradiction. Both received Nobel Prize for their correct interpretation. Mathematical formulation of de Broglie equation. The main equation is wavelength L equal to H upon mu. How was this derived? A very ingenious method was adopted. Planck's theory was already known, and the gist of the theory was energy equal to Hf equal to HCl. H is Planck constant, F is frequency, c is velocity of light, L is wavelength. I repeat this. Planck's theory was already there. E equal to hf equal to hc over L. Einstein mass energy relationship also gives similar equation. E equal to mc square. In equation 1 and equation 2, you can see left hand side is the same energy. It means the right hand side of both equations will be equal. Equating them, hf equal to hc over L equal to mc square. C can be cancelled from both sides, and by transposing L equal to h upon mc. Equation number 3. Here C stands for velocity of light waves. This C letter can be replaced by the popular letter U, which is used for velocity of particles. So we have L equal to h upon mu equal to h upon p. P is momentum. Momentum is given by mass into velocity. So this is the final equation, L equal to h upon p, de Broglie equation. You can see the ingenuity. De Broglie just thought over the two equations, Planck's theory and Einstein's mass energy relation. And he equated both these equations and derived the third equation. What is the beauty of this equation? For the first time, a mathematical equation was derived in which particle nature and wave nature both were present together. Before that, this was considered impossible. But de Broglie obtained the equation mathematically in which one side says it is wave, wavelength, other side has particle nature, momentum. So the beauty of this equation is this. Both particle nature and wave nature were connected together, which were this type of concept was absent earlier and people actually could not believe it. This equation predicts that matter particle as the mass progressively decreases, the wavelength L associated with it increases. That is, the wave particle duality becomes apparent. For what? For very, very small particles. However, for ordinary particles like a ball of say 1 gram, the matter wave becomes negligible, insignificant, as shown by the following calculation. First, we will do the calculation for electron, assuming a velocity of 10 to the power 5 meter per second. So wavelength L equal to value of H is 6.626 into 10 to the power minus 34 joule second divided by mass of electron 9.108 into 10 to the power minus 31 kilogram divided by velocity 10 to the power 5 meter per second. When you work out, you get 0.73 into 10 to the power minus 8 meter. This can be rearranged as 7.3 into 10 to the power minus 9 meter, or 7.3 into 10 to the power minus 9 meter can further be changed to angstrom, the popular unit, 73 angstrom. It means electron has a wavelength of 73 angstrom, which can be measured. Note that here joule unit is kilogram meter square per second square. Now we do the similar calculation for a particle of 10 to the power minus 3 kilogram. If we put the different values of constants, what we get? We get wavelength L equal to 7.3 into 10 to the power minus 37 meter. I repeat, 7.3 into 10 to the power minus 37 meter. If we consider a particle of 1 kilogram moving at a slow speed, that is 3000 meter per second, again wavelength comes out to be of the magnitude of 10 to the power minus 37 meter. We can read these figures But if you look carefully, there is no conceivable technical device which can measure this much lower wavelength. Immeasurable. It means these wavelengths are almost practically absent. Meaning is this: are very, very small particle, wave nature exists, but are ordinary particles, wave nature is absent, does not exist. One more thing I want to clarify. Actually, an electron or atom or molecule, they are particles, but certain of their properties are so that they cannot be explained on the basis of particle nature. They can be better understood assuming wave nature. This is known as wave particle duality. A comparison between matter waves and electromagnetic waves. Matter waves are quite different from electromagnetic waves. Essentially speaking, matter waves are simply very minute particles associated with some wave-like properties. Unlike electromagnetic waves, they are not emitted from matter. They cannot travel in vacuum. They have much smaller wavelength. They have much lower velocity, and they don't possess electrical and magnetic vectors. Electromagnetic waves, we know, they are emitted from particles. They have electrical vector, magnetic vector. So they are quite different. Matter waves are quite different from electromagnetic waves. Support to Bohr's hypothesis. Niels Bohr, the Danish physicist, in 1913, speculated that electrons in an atom are moving only in certain specified circular orbits. And what is the condition? The radius of the orbit was r, then angular momentum m(u)r must be equal to whole number multiple of h upon 2 pi. This was Bohr's hypothesis. At the time of Bohr, this was not proved mathematically. How it originates was not known. But this equation was in agreement with the emission spectrum of hydrogen. Now, the de Broglie theory also proves this equation. How? De Broglie theory says that if the electron wave has to remain continually in phase, the circumference of such orbits, that is 2 pi r, must be an exact multiple of wavelength and L. L is wavelength, N is integer. Thus, 2 pi r equal to NL, putting the value of L, NL equal to NH upon MU. It means MU R equal to NH upon 2 pi, Bohr's theory. By transposing, Mu becomes equal to NH upon 2 pi R, and you know NL is equal to 2 pi R. Therefore, NL equal to 2 pi R. So thus, the de Broglie equation proved that what Bohr had speculated, not proved, was actually correct. It is explicit that the circumference of the orbit in which electron is moving is if bigger or smaller than nh upon 2 pi, the electron wave will no longer remain in phase. This statement is illustrated diagrammatically. We have shown two diagrams here. In one case, the electron wave is continually in phase, that is L equal to 2 pi r equal to mu r. But when NL is not equal to 2 pi r, the waves are not in phase. These are shown by the diagrams. You see, in first diagram, figure 1a, waves are in phase. In second diagram, waves are out of phase. So, Bohr's condition and de Broglie's condition, both are in agreement. So, verification of Broglie's wave particle duality theory. The experimental design is simplified. It is shown here. There is a source of electron beam. They are falling on nickel plate. From nickel plate, they are getting diffracted. And the angle of diffraction is measured. Intensity of waves is measured. Almost same concept which is used for X-ray diffraction. The same concept was applied here. And the experimental results were in total agreement with the wave nature of electron. The following argument establishes that when electrons are accelerated to a potential between 10 to 1000 volts, their wavelength should be comparable to X-rays. Accordingly, they should show diffraction pattern similar to the X-rays. This was found to be the case. Means experiment showed that the behavior of electron waves was almost comparable to the behavior of X-rays. It means electrons are associated with wave nature. Let an electron be repelled by a potential V so that its kinetic energy will be EV equal to half mu square. Obviously, its speed u equal to the root of 2ev over m. And putting the value of L equal to h upon mu, it means h equal to m. Replace u by this value. So we finally get an equation putting the values of constant what we calculated. We calculated that wavelength of electron which is accelerated by negative potential comes out to be 1.26 into 10 to the power minus 10 meter divided by under root V. V is potential. Here one thing I must clarify, electron carries negative charge. If you repel electron by a negative potential V, then its kinetic energy becomes equal to EV. I repeat this point, because electrons carry negative charge. If you repel electron beam by a given potential, negative potential, V phi, then its kinetic energy becomes equal to EV. That concept has been applied here. Now suppose that an electron is accelerated by V equal to 1000 volts. Its wavelength L should be 1.226 into 10 to the power minus 10 meter. The potential is varied between 10 and 1000 volts. Wavelength should vary between 3.877 and 10 to the power minus 10 meter and 0.1226 into 10 to the power minus 10 meter. That is comparable to the wavelength of X-rays. Like X-rays, electron beams were found to be diffracted by nickel crystal, which acts as a diffraction grating. The experimental design is shown in the figure in simplified manner. The experiment gave a direct proof of wave property of electrons. Now that electron wave is similar to X-rays, you can test it by applying Bragg equation. According to the Bragg equation, 2d sine theta equal to n lambda, a very famous equation. You must have heard about it earlier. In this equation, d is interplanar distance in the crystal. Theta is grazing angle for the waves. N is an integer. L is wavelength of the waves. The intensities of electron waves scattered by the nickel plate measured are electrons accelerated by 54 volts. Most intense scattering took place at 50 degrees. It corresponds to the wavelength L equal to 1.668 angstrom. This wavelength lies in the range of X-rays.